So my class that doesn't have the we don't meet in lecture, they've been using my videos to learn, and they think my jokes are funny.
Is that what they're putting underneath the
That's
comments?
that's what they say for extra credit. I said my jokes were funny. So even Siri says so. So the next two sections, well, the rest of this chapter pretty much is going to be, I don't want to say hard because I don't want to discourage you guys, but just be sure you don't get behind at this point. Be sure you understand everything, like everything, life, love, you know. So this is polynomial theory. Polynomial theory. Part 1. So you know when something has a part 1, it's going to be good. What's it all fuzzy for? Focus, Danielson. There we go. Okay. So the first thing we're going to start with is the intermediate value theorem. Okay. So this is the intermediate value theorem. I think I kind of already mentioned this at one point. What this is basically saying is, if you are in the United States right now at noon, and then you're in Sonora, Nogales, Sonora at 3 p.m. this afternoon, there must be a point when you cross the border. Do you guys agree with that?
What does that say after value?
Theorem? Theorem. Yeah, my handwriting's horrible today. Theorem. So, would you guys agree that if I'm in Tucson right now at noon, and if I'm in Nogales, Sonora at 3 p.m., I had to cross the border at some point? Why? No? Why?
Because you could have probably stopped at stores or something before.
I could have stopped at stores, yeah, but at some point between now and 3, I had to cross the border. Well, maybe I'm lying, so that's good that you bring it up. Is that true or false?
Seems true.
It's true? You guys don't sound, not everyone's convinced.
What other variables are there? You already crossed. That's what you're stating.
What I'm saying is I'm here in Tucson, and then I go south to Nogales, Sonora, and at some point in the next 3 hours, I'm at the border.
You're at.
I cross the border, or I'm at the border, or some, you know, whatever, however you want to phrase it. I might be under the border in a tunnel, but I'm at the border still, right? Like, I might jump over in a catapult, but I'm still at the border, right? Is that true or false? Why? What if I have a Star Trek transporter, like I disappear right here, and then I reappear in Nogales, Sonora? Did I still cross the border? No, I just disappeared right here and reappeared over here. Now that's not very likely, right? No one here has a transporter. So what's the difference between a transporter and the way we have to travel right now? It's this idea of continuity. So polynomials are continuous. That means you can draw them without lifting up your pencil. You don't transport to another dimension, right? So if you think about this, If I'm over here, if I'm positive, right here, and then later on at 3 o'clock, I'm over here. Let's say this is the US and this is Mexico. There has to be a point where I cross the border, right? Now I could cross it early and take my time in Mexico. I could finish class and then go there later. I could go, come back, go and come back a few times. Doesn't matter. But I crossed at least once, right? And vice versa for if it's the other way around, right? If I'm in Mexico and then I'm in the United States, there has to be a point where I cross the border, right? I guess the only way it's not possible is on the Earth if you were to fly south and go around the North Pole and then come back on top. But that's a special case, right? That's not like graph paper, right? So what this says is if P of A is positive, and P of B is negative. Do you guys know this term vice versa? Or vice versa? That means P of A could be negative and P of B could be positive. Then there is a point C in between A and B where P of C is equal to 0. So if we call the x-axis the border, the wall, right? If you're here on one side and then at some point in the future you're on the other side, you had to cross it somehow. You are at it somehow. If I'm driving on I-10 from Tucson to LA, let's say I leave Tucson at 8 a.m., I get to LA at 4 p.m. on I-10. Is there a point when I was in Phoenix? I have to go through Phoenix, right? Because I said I'm on I-10. Now, I'm not talking about bypass routes or anything. Is there a point when I'm in Blythe, in Quartzsite, in Riverside? Well, I don't know about Riverside. The area. Right? There's a point when I cross the California border, right? There's a point when I cross the Colorado River. This is all that this is saying. What this is this is an existence theorem. This is saying, this is why we're so happy about it. A zero. What's other words for zeros? X-intercepts. Factors exists. A zero exists. Zero is the name of the game in this chapter. If you find zeros, you find factors. If you find factors, you find zeros. If you find x-intercepts with a graph, you found a zero. You found a factor. There's many ways to solve these solutions. So this is saying that there is hope. Now this is actually what you do on your calculator. How do you find a zero on your calculator? What are the steps? So let's say we press calc 0. What's the next step? Enter what? Left bound, right bound. What's special about the left bound and right bound? One was going to be positive, one is going to be negative. Or one is going to be negative and one's going to be positive. That guarantees there's a zero in between there, right? So you kind of been using this whole time. So show that P of x equals x cubed minus 2x squared. I don't know why it gets blurry like that. I'll fix it later. X squared minus x plus 1 has a 0 between 2 and 3. In other words, if I were to graph this on my graphing calculator, and I chose my left bound to be 2, and I chose my right bound to be 3, is there going to be a 0? Why? Prove it to me. Like, this is a court of law. I'm the judge, and you're the lawyer. And you must prove to me there is a 0. Between 2 o'clock and 3 o'clock, you crossed the border. That's what we're asking right here, right? The defendant says, no, I never crossed the border between 2 and 3. Like, well, I have a picture of you. At 2 o'clock, you're in the U.S., and at 3 o'clock, you're in Mexico. Your Honor, you crossed the border in between 2 and 3 o'clock. So what you got to do is you got to prove that you're on one side at one time and you're on the other side at another time.
So do you need 2 points?
Yep. Now let me show you again. I've already showed you guys this before, but let me show you a way to do these quickly. Instead of typing this in, 2 cubed minus 2 times 2 squared and everything, let's just do it once. X cubed minus 2 2x squared minus x plus 1. So I can do this a few ways. One is I can go to second table and I can see what is f of 2. What is p of 2 going to be? P of 2 is -1. P of 3 is 7. What's another way to do this? I'm just going to show you different ways. Another way to do this, remember this y1 problem? Alpha f4 y1 of 2. Basically, I'm saying, where were you at 2 o'clock? Oh, you're on that side. You're on the bottom side. Where are you at 3 o'clock? Oh, you're negative and then you're positive. Therefore, there is a 0 in between. So you can do it using this method. Notice that these numbers are the same as these numbers. But if I wanted to find 2.5, I'd have to do this way, right? So the second table is probably the easiest way. P of 2 is -1. And P of 3 is 7. Therefore, there is a 0 between 2 and 3. Now, why is this important? Well, because if I'm looking for zeros just using this graph, this table, where am I going to look? Wherever the sign changes. So notice I can find another one right here also, right? But let's find this one. So there's a few ways to do this. One is the calc. Actually, I'm not sure if this one has a 0. F min, F max. Yeah, it doesn't. So the way we're going to solve it is via the graph. Here it's negative, here it's positive. I'm going to go to second calc 0. Now this doesn't have to be 2, but just to prove our point, let's make it close to 2. Notice that it's negative. So sometimes people say, I tried this and I didn't get the answer. You have to have a sign change. In other words, if I go from here, this is negative, to here, it's still negative, you're going to get an error. So sometimes some students say, why didn't I get what you did? You have to cross the border before they build the wall. Guess. 2.24. So x equals 2.2, I think it's actually 2.25, right? If I round it.
Yeah.
2.247, how about that? So at 2, this is right before 15. So at 2:14, Your Honor, John was at the border.
So you got that number by getting the 0,
Mhm.
but how do you get that number by looking at the charts?
This number?
Mm-hmm.
You can't. All I can do is say, if I focus my energy between here, I'll find them.
It'll be between 2 and 3.
Yeah.
So you don't want us to find the zeros for the other two where it crosses?
We can, but for right now, we're gonna do it. So, but for right now, I just wanted to show, if you're looking for zeros using a table or something, this is how you would say, okay, look between 2 and 3. Now, sometimes we have to zoom in and zoom out on the graphs, right? So this is what I'm saying. Like when you don't know, you can use a table to scroll up and down really quick, and then you find a search right here. Search your video, your camera footage between 2 and 3 o'clock, and you'll see him handing off whatever he's handing off, his passport to the, I don't know, the story. I can't extend the story no longer. Does this make sense? So now we know that there's zeros and we can find them. Now, did I show you guys synthetic division already? No? Okay. So, polynomial division. Now, we already know that zeros are factors, right? So, what if I were to say factor 21? How do you factor this? You start with maybe 2. Is it even?
No, it's not.
No, so it's not divisible by 2.
3 and 7.
How do you know if it's divisible by 3? What's the trick? You add the digits together and see if that's divisible by 3. 2 plus 1 is 3. Is 3 divisible by 3? Yes. So then what I do is I divide 21 by 3 and I get 7. So what that shows me is this and this gives me, well, what am I actually doing here? Let's be very specific. What I'm doing here is 21 divided by 3 equals 7, right? That's what this problem is right here. This gives me that 21 equals 3 times 7. So I need to know division to find the factors. Let me give you an example. I gotta use my calculator. Calculator. Factor 123. Off the top of your heads, what is it? I don't know, right? So how do you find it? What do you do in your calculator? You're basically doing this. Was it divisible by 3? Yes. So you do this and you get 41. What is the remainder? The remainder of 0 means it is a factor. Well, you know what? I might as well just keep doing this over here. So, what if I say 21 divided by 4? What is that?
Remainder 1.
So it's 5 remainder 1. You guys agree? Now another way to write this is, this means that 21 equals 5 times 4 plus 1. Would you guys agree with that? If 5 and 4 were factors of 21, this would have been 0. Would you guys agree? There's nothing mysterious about this. You guys learned this like in 3rd grade, right? Whenever you learned division. Maybe 4th grade, I don't know. Maybe you never learned it. Let's learn it now. All right. Now let's do something harder. I'm just going to give me 4 numbers randomly. Anyone, just shout out. 4 digits. Huh? All right, well that works, I guess, too. We'll put both of yours together. 10, 25. Divide. So let's give me 2 numbers. Or just give me a 2-digit number. How about that? 11. I heard 11 first, sorry. How do I divide this? Well, does 11 go into 1? Well, it does, but it's 0. That's not interesting. Does it go into 10? No. Does it go into 102? Yes. It goes into it 9 times. 9 times 11 is 99. How do I get this 99? I multiply the 9 by 11, right? You guys are like, come on, Morales, we're seriously doing this? All right. Just remember how easy this is. 9 times 11.
I'm being serious.
Yeah, you have to know this or you won't know the next part. So you take 9, goes into it. Then you multiply 9 times everything over here, right? This is 99. Now I subtract. Does that make sense? I subtract and I get 3. I drop down the 5. And I redo the process. I say, how many times does 11 go into 35? 3. I multiply by 3 by everything over here. And I get 2. So I can write this a few different ways. I can write it remainder 2. Or I could write this 93 and 2/11. But what I also know, which I care about for this chapter, is that 100 or 1,025 equals 93 times 11 plus 2. Would you guys agree?
Mm-hmm.
You doubt me? Check it. All right, let's extend this now. Oops. You're like, all right, Morales, let's get to algebra. Okay, fine, here you go. Have at it. How do I do this?
Just do long division.
Yeah, can you factor it? I'll give you a hint. No. So what are you going to do now that you can't factor it? Right. Well, what did we do in the previous one? We had to do long division, right? Because I'm not like that good in my head. Like I can't do 1,025 divided by 11. Or can I? You guys know the trick for multiplying by 11? Give me a 2-digit number. 22 times 11 is 242. Yeah. Give me another 2-digit number.
26.
26 is 286.
17.
17 times 11 is 187. You add the digits together and put it in the middle. Dang. Check that out. Oh yeah, but what about 2 and 9? Maybe I was lying. Because you put the 2 and you put the 9, but what's 2 plus 9?
So it'd
Yeah, so it'd just be,
17 times 11 would be 197.
what's 1 plus 7? How about this? What's 7 plus 1?
What's
8. So 187.
Oh, never mind.
So here, if you do it this way, you just have to carry the 1. Now you guys just learned some. Now you guys got math skills for the weekend.
I'll probably forget.
This is unforgettable. So we gotta divide. You guys ready? Deep breath. Now, if you guys took my 97 class, we already done this, so this is no big surprise. Anyone take my, few of you? I like to torture my students early on, so what you got to do here is you got to have every power has to have a place. This is a big development for Western civilization, like Europeans and stuff. They couldn't figure out the zero problem until like 500 years ago. That was the big thing, right? Zero. It's not there though, look. It's not there. But it is there. See the difference? Here it doesn't exist. Here it exists, but with a zero quantity. Is that the same thing? Because one exists, one doesn't exist. It doesn't exist here, but here it exists. It's just non-existent. I have no philosophers in this class. That's a deep thought if you think about it, right? One of these days you won't exist, but you existed. But there's a lot of things that never existed. So there's a difference because you once existed. It's after lunch, no deep philosophy. Right? So what do? Follow along. I take this x. I have a lot of x's that exist. So x, I divide it into the first one. What's 3x cubed divided by x? 3x squared. I write it over here because I want everything to line up. I take this 3x squared and I multiply it by x and by minus 3. So it's 3x cubed minus 9x squared. I'm going to pause for a moment. Do you guys see where I got this? 3x squared is basically what I'm doing over here on the side is 3x cubed. See this right here? Divided by x. And that's 3x squared. So I put that over here. Then I take this and I multiply it by everything over here. Isn't that exactly what we did on this last slide? I take the 9 and I multiply by everything that's over here. That's what I'm doing here. Would you guys agree? Would you guys agree with this green part right here? Now here's a part where students sometimes mess up. The way I do it to not mess up is I just put parentheses around it and put minus. Sometimes students will try to do this on the fly and then you'll mess up. To this day, all the math I know, I still do it this way. There's not really a good shortcut to it. Just do it this way. You won't mess up. 0 plus 9. Now, first of all, you know you did this right if the first term goes away. If something still remains here, you did it wrong. It's gone, right? So now I say, okay, what's 0 plus 9? You guys have the calculators, not me.
9.
0 plus 9 is 9. X squared. I drop down the next term. Now I can actually drop down all terms if I wanted to. It doesn't matter. It's up to you guys. Okay? Now what did we do over here? I have a 3, I drop down the 5. And then how do I get this 33 here? I look back at this 11 and say, how many times does 11 go into 35? How many times does x go into 9x squared? 9x. Nine x times x is 9x squared. 9x minus 3 is minus 27x. Don't try to be clever, just put the parentheses with the minus sign. It's not really a shortcut. That'll be where most students mess up. That's why I'm telling you guys from the past. Like, I just see all these little mistakes. And then guess what? Then you get it all wrong. And then you get 0 points. And it's unnecessary. 9x squared minus 9x squared is gone. Good. Minus 2 plus 27, 25x. Drop down to 5. How many times does x go into 25x? Plus 25. The other good thing about this method is you know you're done when you reach the end here. 25x minus 75 is it minus 70?
Why did you put the parentheses with the negative on this one?
Well, exactly. I'm trying to see who's listening. It's not minus 70, right? What did the teacher do this time? But you can see how this answer might come out, right? So that's why it's very important to put the parentheses with the minus sign.
How'd you get 25?
Right here? Minus 2 plus 27. Or you can think of it as 27 minus 2.
Okay, put the 25 on top.
Because x goes into 25x how many times?
Okay.
25 times x is 25x. And what's left over?
80.
80. And sometimes my math lab will say, what is the quotient, what is the remainder? With 2 boxes. Sometimes it'll say, put the whole thing in. So then you would put 80 over x minus 3. Because 80 is not, because this is not 0, it's not a factor. But what do I know? I do know that 3x cubed plus, well, let's write the original one, minus 2x plus 5 equals x minus 3 times 3x cubed, oops, yeah, 3x squared plus 9x plus 25 plus 80. Because this is nothing more than this up here. But this 80 messes it up, right? So I don't really care about this factorization. Not interesting to me. But my math lab will ask you about it. What I do want is when there is no remainder. Because then when there is no remainder, I factored it completely. Make sense? Now, this looks a little messy. Let's see if there's a shorter way to do it. So, you guys got this? Let's do the same thing. So when dividing by x minus k, notice that this is linear. This is not x squared plus 3x plus 5 or so. It's x minus k. We can use synthetic division. This is how it works. So the previous problem was 3x squared, 3x cubed minus 2x plus 5. You guys have it written down, but there it is, okay? Now this is how we can, there's another way to do this. You see this number right here? What is k in this problem? 3. It's not negative 3. Do you see why? Because it's minus, right? So I take 3 here. And then I go like this. 3, 0, negative 2, 5. Do you guys see where I got those numbers? Everyone see where I got those? I'm not telling you, I'm just seeing if you know. Right? Then, this is the way I do it. And every book has a different method. This is the Morales method. It's the best. Because otherwise, I would do something else, right? Why would I want my method to be inferior to another method? So, all right. This is how it works. You guys ready? Take this number and you add it to whatever's right here. Now there's nothing here to begin with, right? So it just drops down. Boom. You take whatever number's right here, multiply it by that number, and put it right here. 3 times 3 is 9. Add the numbers. You guys have the calculators. 9 plus 0 is 9. 9 times 3, 27. 27 minus 2, 25. 25 times 3, 80. Now look, this is how it works. This is the constant term, this is the x, and this is the x cubed, or x squared. So this is 3x squared plus 9x plus 25, remainder 80. Yep. But it's a shorter. The other one's long division. This is not long division. Now, this is important because you're going to do it about 100 times at least in this chapter. This is very, very important. It's important for two reasons. One, it gives you the remainder. Two, it gives you what the quotient is for free. You didn't even ask for it, and it gave it to you. It says, here, take this too. Well, that was awfully kind of you, sir. You guys got it? Try it yourself. I'll leave this here. Now notice that this, you can see all the numbers. 9, 27, 75. 9, 27, 9, 27, 75. You know, everything's there. But this way is a lot faster. So do 5x cubed minus 6x squared minus 28x plus 8 divided by x plus 2. This synthetic division has become like second nature to you. You know how you memorize the multiplication chart? You have to just learn this. Now we're like, well, I got cell phones. I don't even memorize anything. I don't even memorize my parents' phone number. Just scroll down. You just ask Siri, right? Siri, call mom. And then check with your neighbor when you're done. See if you guys have the same numbers. Is this right? How many of you guys did it this way? Good. This is wrong. Why is it wrong? Negative 2. 5 comes down. 5 times negative 2 is negative 10. Negative 16. 32. 4. Negative 8. Uh-oh. Whoa. What does this mean? That means this is a factor. Ah, this is good. So what this means is that 5x cubed minus 6x squared minus 28x plus 8 equals x plus 2 times 5x squared minus 6x, oops, copying the wrong thing, minus 16 x plus 4. That's kind of cool. Finding a zero when the remainder is 0 helps me factor the problem. Once you factor the problem, you know everything about it. The final answer is this right here, the 5x squared minus 16x plus 4.
Not the X plus 2.
The final answer would be this. This right here. Let me do it this way. This right here equals. That's the final answer. But you can use this to factor it.
Just a random question. Why don't you include the x plus 2 in the final answer? I'm just curious.
Well, here's the x plus 2 right here.
No, I know, but in the final answer, because you said the root's the final answer, so why isn't the x plus 2?
Because this does not equal this unless you're dividing by this. Right? Like 12 divided by 3 is 4. I don't include the 3.
Okay.
Right? So this is a good point to take a little break and try to understand this if you don't. All right. That's interesting. So I teach pre-calc before this, and we're kind of doing the same thing. That book actually does, they have a different notation for this. What the way they would write this would be what, -2, they write it underneath. I'll use a different color. So depending on your book, they'll use different symbols. Actually, I've seen some that do this also. Well, you know what? There's actually about 3 or 4 different ways. Use whichever way works for you. But there's something else that's special here. Calculate. So this is P of X, right? This right here. Calculate P of -2. So plug in -2 right here, right here, right there. See what you get. Mm-hmm. I'll let you guys do that part. What do you get? 0. What's special here is when you do synthetic division, the remainder is actually that value. So let's write this out in a theorem form. Remainder theorem. This is like kind of magical, I think. If a polynomial P of X is divided by X minus K, the remainder is P of K. So we just saw in the last one, when we divided by X plus 2, and we got the remainder 0, that means P of -2 is 0. Now the power of this theorem is when you go the other way. For example, let P of X, so this is an example, let P of X equal -x to the 4th plus 3x squared minus 4x minus 5. Now, to appreciate this problem, I want you guys to do this by hand, okay? So you can see the mechanics, all right? So don't use your calculator or your cell phone for this. Ready? So find P of -2 by hand. So it's 115 right now. It shouldn't take like more than 2 or 3 minutes. It's just so when you're done, just shout out done. Remember, we're not using our calculators on this at all. So like this is a very, you know, it's -2 to the 4th plus 3. This is a problem we all should be able to do from like a few math classes ago, right? Did anyone finish yet? So it took about 2 minutes, right? So everyone did this, right? And then how long did it take to do it? It took about 2 minutes. Let me show you another way to do it. -2. -1, 0, 3, -4, -5. Now you guys could time me, all right? -1, 2, 2, -4, -1, 2, -2, 4, -1. So the answer is -1. Which way is easier?
Where'd you get the zero? Oh.
Where'd I get what? The remainder theorem says that this is P of -2. That's what this says right here. So I was able to calculate P of -2 not by doing this, by doing synthetic division. That's weird, isn't it? This is a calculator too. You have to be careful because now you have to carry this, the signs and everything. You might mess up. What if I make this a little bit bigger? What's 5 to the 4th power? We're already talking about big numbers, right? But synthetic division is just adding, multiply, adding, multiply, adding, multiply. So anytime I want to calculate a number, I can just do synthetic division on it. And it gives me the answer. I'm going to let you guys just stare at this for a little bit and marvel.
Like a piece of art.
It is. Who would have thought that doing synthetic division and seeing the remainder is the same as calculating the value of the function? Question?
How did you get -2? Like, where'd you get it?
I just chose it out of thin air.
Okay.
So I just decided to torture you guys. Calculate it. Right. So now if I wanted to if I wanted to calculate P of 1, I would do this again with the 1 here. And then get the answer. I think that's cool. If you don't have calculator back in the day and you start doing harder numbers, this is a nice way to do it. Right? So now what's nice is if this is 0, then it's a factor. Right? So our goal is going to be, let's make this 0 somehow. Let's find the zeros. So determine if the given number is a 0. So 2 problems. 2. So this is 2 different problems. Determine if 2 is a 0 of this, and determine if negative 2 is a 0 of that. Now I just showed you a shortcut, right? Sure, you can say, all right, what is 2 cubed minus 4, 2, whatever, blah, blah, blah. We don't want to do it that way. Use your new method. What does the new method say? It says if I put a 2 right here and divide into this, this number right here is going to be P of 2. That's the magic. The remainder is the value of the function. It's weird. It shouldn't be this way, but it is. It's a perfect pairing. I can't believe a woman this beautiful would be interested in me, but she is. I don't know why, but it works. All right, so then you do it. 1, 2, negative 2, negative 4, 5, 10. Uh-oh. What do I get? 0. Now look at the level of math I did here. Basic arithmetic. The level of math you have to do here is not that hard, but now you're doing exponents. And if this is negative, well, look at this next one. Who wants to do negative 2? You have to count as it negative is positive, and then I got to worry about this 3 halves. That looks a little messy, right? Well, I ain't afraid. I know some magic. I got skills. Is this right? What's wrong? You gotta have a 0 for the constant term. Alright, looks a little scary, but whatever. First of all, our calculators do fractions, right? You can do math frac. But this is what's nice about this problem. What are the denominators of the function of the numbers here? 2, and what am I multiplying by? So guess what's going to happen to them? They're going to magically disappear. More magic. I just can't can't stop the magic today. So how do you multiply by 2? You just cancel out, right? Well, first of all, it's just 3 halves. Times 2, negative 3. Minus 1 minus 3 is
2.
minus 4. I owe you $1, and then I owe you $3. I owe you $4. Right? Uh-oh. Now they look scary. 8. Put it in your calculator. Now, of course, I could do this in my head. It's just 16 plus 3, but just to show you guys, in case you are afraid of fractions, it would just be 8 plus 3 halves, right? You get a weird number, you press math, enter, and you get 19 halves, right? Your calculators do fractions, so we're not afraid of fractions. It's just this is nothing for the calculator. If you wanted to do this, the way I did it in my head was, okay, this is 16 halves. 16 plus 3 is 19. Well, this looks scary, except I'm multiplying by 2. No big deal. What's my remainder? Therefore, what is P of negative 2? Negative 19. Is this a 0 of the function? No. But if you plugged in negative 2 into here, which, does it look, who wants to do it? Who wants to volunteer to do it on the board? I won't let you. I'm mean, but not that mean. That's not that bad a problem. But this is easier. That's a 3. I got so excited, I could just see the excitement in this room. Like, this is my last class before spring break. Hurry up, Morales. Well, guess what? This is my last class before spring break. Don't you wish? Okay. I will. You know, I only got a few more problems, and then if we finish those on time, maybe I'll let you out like at 2:04 instead of 2:05 today. So, such a nice guy. All right. 2 of x cubed plus 5x squared minus x minus 6. Show that negative 2, negative 3 halves, and 1 are zeros. The only thing that's unfortunate is that the title of this chapter was like Polynomial Theory Part 1. So what do you think is coming next?
Part 2.
But Part 2 comes after spring break.
That's
So-
the easy part, though, right?
No, that's the fun part. Now the question is, what are the chances that you all remember this after spring break?
None.
Now the good thing is that you can roam for free in Mexico. So while you guys are on the beach drinking your margaritas, you can go to mymathlab.com and so back in my day we had to take books to the beach.
I still do.
We still do. But we're not talking about ones with Fabio on the cover. His hair flowing. Well, the next time you guys are sunbathing at Silverville Park, you know, Kennedy Park, catching some rays as the kids go swimming. So you guys are becoming experts with synthetic division now? It's all synthetic division. Synthetic division is there's something else that's going on that's going to be key to the next chapter. So that's why you have to master it. Now I'll do it the other way. This is another way, another book will show you to do it. Actually, what I'm going to do is take attendance right now. Yeah. So then you get 2, -4, 1, -2, -3, 6, 0. So it's, yeah, they're all similar. The numbers are in the same place, but lines can be different. All right, so you guys did the other ones. Now this is what's important is can I sketch a graph of this? Maybe. How would I sketch a graph? So whenever you see a sketch, that means don't use your graphing calculator. What would a graph of this look like? Now this is like -1.5, right? So it'd be -2, -3 halves, and 1 over here, right? Now I know that these are zeros, right? Therefore, the graph goes through those points, right? The question is, how does it look everywhere else? It's third. Well, what's the end behavior? It's so for you guys, would it be like this or would it be like this? You guys never seen Saturday Night Live or Saturday Night Fever? So it would be like that, right?
Yeah.
Why? Because this is odd and this is positive. So therefore the end behavior has to be, it goes to negative infinity on this side and it goes to positive infinity. So it has to look like that somehow. So let's graph this then. Y equals and then I zoom 6 because I don't know what I did last time. Does that look kind of, well, more or less, right? It goes up at 3 and then comes back down at 3 or 2. And then at 2. So you can see here at At -2, it goes up, and then at a half over, it comes back down, and then it goes back up at 1. Now this is what's important. The relationship. Remember, this is polynomial theory, where we want to know everything there is to know about polynomials. You'll see why. The zeros, the factors, and the graph. Now look at this graph right here, right? I could start from this graph. How do I find the zeros? Well, 2 of them are pretty obvious. If I go to my table, -2 is a 0, and 1 is a 0, right? The other one is in between here, right? How do I find that? Well, how do I find zeros this whole time? 0. So you go a little bit to the left, to the left, to the right, to the right, to the front. You guys just aren't feeling it today, huh? Like, I'll be singing that at the beach next week, but not right now. -1.5. So I found my 3 zeros. So if I start with the graph, I can find my 3 zeros. If I find my 3 zeros, if I started with this, I could then get this. Would you guys agree with that? But that doesn't look like this. Or does it? It doesn't, huh? So what's wrong here? Why doesn't this, because what I mean it doesn't look like this is, look, x times x times x is x cubed, right? This is 2x cubed. So the way you fix this is, you see this fraction right here? We multiply by that fraction on this one right here. So you multiply by 2. Well, that's how I fix it, right? I multiply by 2, right? Now it's equal. But if I distribute it to this one, you get x plus 2, 2x plus 3, x minus 1. Now on a test, I would accept either 1. But my math lab is probably going to want this. It doesn't want the fractions part. It wants this one. Now, is the leading coefficient equal? Yep. X times 2x times x is 2x cubed. So notice the circle of life here. The zeros, the factored form, the graph, the x-intercepts are all the same thing. It's like a trinity here. The zeros, the factors, and the holy graph. So, they're one and the same. They're different manifestations of the same thing. Dang. That's deep. Now, we'll do, we could fit in about 14 more problems. X squared plus 1. Actually, you guys don't even need to bring your books to the beach, because my videos are on YouTube now. You could just watch on YouTube with the piña colada, e.g. And, you know, it's a long drive too, so you could just listen as you're driving.
You should start making ebooks, or what do you call it, audiobooks.
You could read my talk about this finding the zeros at the border. You could be like, hey, he's talking about the border, I'm at the border. Dang, that's crazy. So this is a little bit different than what we've done so far. Why? Can I do synthetic division?
Sure.
Nope.
Why?
Why?
Oh, it's the X squared.
Synthetic division was something. Oh, when dividing by x minus k. Not x squared, not x cubed, not x to the fourth, not x to the fifth, not x. Here, shut up, Art. Not x to the seventh or the eighth. All right, it's the same process. How many times does x squared go into 5x cubed? So it goes way over here. 5x. 5x times x squared is 5x cubed. Would you agree? 5x times 1 is 5x. Uh-oh, what's wrong here? This is a very common mistake I'll see. Line up. So there's nothing wrong here technically, but students will sometimes say minus 4 plus 5. The trick here is always line up your powers. Plus 5x. See how they're always lined up? 5x cubed minus 5x cubed is 0. But don't forget that this comes down as minus 4x squared. And this comes down. Any questions? What's next? X cubed, x squared goes into minus 4x squared. How many times?
-4.
Minus 4. Minus 4. Is it minus 6? Plus 2. You know you're done once you're done here. Once you get to the numbers over here, you're done. So this answer is 2x plus 2 over x squared plus 1. You could write remainder 2x plus 2, or you can just write it this way. All right. I think, okay, well, I don't think, I know I've shown you everything you need to know for this chapter. So I want you guys, if you will agree with me that you're going to take this knowledge and go forth and spread the math.
Why is the X squared plus 1 on the bottom? Why do we need an X?
Why is this one?
For the answer.
Well, because that's what you always take this part and put it right here.
Are you gonna be posting the homework for this?
Already did.